I'm going to explain about the online condition monitoring system for hydraulic system. So myself Maulik Prajapati, 14 MMT 1036 from MTech. So why we are going for condition monitoring for hydraulic oil? Because it is the most important thing in a system or in a cylinder. So, we have to maintain the oil coverage because it increases the investment cost, demand for longer maintenance time, interval, high system, less downtime and a breakdown. And also due to shorter mean time between the failure and is focusing machine manufacturer to incorporate condition monitoring system with their machine design. It also involves that the corporate around the clock under difficult operating condition away from the professional maintenance. So here we have to maintain the quality of the oil and how it is performing the machine. So, the main point, the main discussion we have to do only the how to monitor the oil by using the sensor or any other technique. We will discuss furthermore about it. So today I am going to discuss only on the online condition monitoring method that is suitable for monitoring a single hydraulic component or entire hydraulic drive, or can be used for a hydraulic fluid. So in case of the hydraulic fluid monitoring, special attention is paid to the knowledge of the fluid that are physical or a chemical property and their changing mechanism, particularly the fluid aging process. Nowadays, what the increasing investment cost of the machine, the demand for longer maintenance interval, and the higher system reliability, lesser downtime and breakdown, and their desire to shorten the mean time between the failure. Uh, this process mainly forcing the manufacturer of machine to incorporate condition monitoring system with their machine design, especially in one machine that operate around the clock under difficult operating conditions and the way for professional maintenance staff. And it is very important for the machine with built-in hydraulic drive system where the constant monitoring of equipment status as well as hydraulic fluid is required. So we have to maintain the hydraulic fluid as much as possible. So how the hydraulic fluid is damaged because of as shown in the diagram, the damage occurred due to the most important the particle, the contaminant that is contained in the fluid that will damage the oil. Second, the vibration. Third, the noise and the temperature. Most important phenomenon that is affect the nerve because of increasing the temperature, the viscosity will also be affect smoke. Because of the smoke there is a chances of fire, and so how the damage is occurring that is shown in the diagram. So what are not only the oil but we have to see the what are the components involved in the oil. So for that we have to do the condition monitoring. So condition monitoring of hydraulic equipment component can be arranged in two different groups into a simple measure for component monitoring or a simple empirical measure based on the advanced method of single acquisition conditioning. So first method we can go for the simple approach for basic component. One of the simple case is represented by the continuous monitoring of filter element within a hydraulic system. It can provide valuable clue to the performance of the filter and also the condition of the system. The warming of filter bypass is typically affordable by visual or electrical clothing indicator. So here for the simple approach we are using the electrical clothing indicator. So when the oil will pass through the filter, the clothing indicator will describe how much the waste, how much it affects the oil. That all will indicated by the electrical clothing indicator. So this device indicate where the pressure drop across the element is approaching the opening pressure of the bypass valve. So in case of the return filter, for example, when the oil is coming, the bypass will open at the delta P for 3 bar. So it depends on the how much pressure we are doing. The floating bar will indicate typically 2 bar. So these are the online monitoring system, hydraulic system as I mentioned is electric floating. So here the between this filter is there. So when the seen in the diagram that when the oil will pass through filter, this filter will filter the oil and it describe by passing the oil, it also describe how much pressure involved in it. So when the pressure involved, if it describe more than 3 bar or 4 bar, the 4 bar, so the filter will pass to the output, and if we go against him, the pressure will be, if there is some difference in the pressure, we will definite we find that there is some problem, there is some particle in the fluid, so we can see whether the pressure difference between the in and output of the fluid, we can find the effect in the pressure. So if the oil will go above the pressure level, so above the pressure level, so we have to change the filter. This filter should be changed if the pressure, if it go above the pressure level. So second, as I told, second is for the advanced approach for the complex system. So here we will dealing with the five component for the system: magnet, dynamic of tube, valve flow rate, drive, and loading mass. So each will give their description according to magnet will it will what are the magnet will identify the particles in the oil, dynamic of the fuel, how much the valve flow rate is lower, what are drive will be used, and what are the mass, how much the load it can use. So according to this all three parameters, we can find what are the approach to simplify the hydraulic oil. So when using a detailed model system, we are able to track and any break change in the system performance down to a single parameter that can be directly interpreted by this physics. So example, the structure of a hydraulic linear tie in the form of series connected block model, which can dynamize individually or combined with the use of model based fuel monitoring system. Modern based approach of hydraulic linear drive, the condition of the magnetic actuator and the fluid dynamics of physical control valve can be monitored using the variable signals such as voltage, gauge, and displacement. So as I shown in the diagram, this all can be controlled by the voltage, current, or this all can be controlled by these three parameters. So we can therefore use different possibility of this failure diagnostic on a proportional scenario. When using an example, for example, a modern with a distributed parameter, we can reconstruct the armature or spool position by use of current or voltage signal. So I already discussed that the signal by using the parameter of voltage, we can use the signal calculator due to the high computing power necessary. This needs to be calculated offline at an interval of about 5 seconds. So every 5 seconds, this value has been taken, and it is taken into advantage, so that structure for the use of diagnostic function is can be acquired. The measuring data needed for the control are made available on the use. So all these signal voltage displacement are go to the microcontroller, and it will identify what are the errors that is shown. So diagnostic function have access to the internal signal and capable of accessing additional information by the field bus use. So this is a diagram shown when the fluid is passed from the cylinder by it go for spool, by applying the pressure, the spool will move, and the drive will actuate it. If this dry is giving the signal in the form of the current, voltage, or a displacement, this parameter will go for the microcontroller processor, and this is, if any this microprocessor output will go for diagnosis technique, and it will go for control loop, and what are the errors, we are finding, this again will go for the solenoid valve. So according to this is a feedback loop system. So this also can give the feedback. So what are the error we are getting, if there is any particle or a contaminated air inside of fluid, we can easily identify by using the feedback system. Condition monitoring system, what are main factor of the condition monitoring system, what are the elements that affect the fluid. First, the water. Because of the water, the mix of oil and water, there is a chance of corrosion. Second, the oxygen. The oxygen. Third is pressure. There is a lot of pressure difference that is not required in any fluid. Third is what are the particle, as you already discussed. Because of particle, there is a wear and tear of the machine. Third is shear strength that occur in the radiation, temperature. As I already told, the temperature main because of the temperature increase, the viscosity also will be affected. Oil quantity, what are the because if more oil will be wasted, the oil quantity will reduce. These are the things that we have to consider in the physical and chemical way of the controlling of the fluid. And what are the we can use that use this improve this we can use the filter for this for monitoring of fluid. So for monitoring we have simply find a sensor which can determine all these factors: water, temperature, pressure drop. All these factors can be determined by one sensor. So if this sensor contains the dielectric property, voltammetric potentiometer, optical property, conductivity, temperature, and this mass. Is all this one sensor, it can determine all these particles that is required in the fluid. In order to have all important about fluid condition online monitoring system in following physical these are the measures that can be found in the fluid. First, temperature. So one of the basic and most important physical quantity that requires continuous monitoring. The temperature is the most important thing that is required in the control. Secondly, fluid thickness level for changing wear and tear or a wear pattern with online particle sensor or a wear sensor helping you make the informed maintenance planning. So, viscosity as physical property of the mineral hydraulic oil which affect the lubricants coil and also the friction and the wear. Fifth one is called humidity. Humidity, the water in a particle, one of the greatest threat to the hydraulic and lubrication oil. The sixth is relative permeability as a measure of the fluid porosity is depend on the basically oil type and the additive package. Porosity of the fluid is a quantitative factor to which oil change, oil mix, and refreshment can be detected. So as I told the sensor, this is the one of the sensor that is used for the hydraulic monitoring of hydraulic oil, and this all in the latest research they have been, this has been connected with the lab view, so we can get the data. What are the error we are getting? We can find in the lab view. So this is the online condition monitoring sensor that I shown in the figure. Thank you.